Hey guys, welcome to Math Engineers. This is Akanksha Sharma, and here we have a famous problem from 2018 MIT Integration B. The Integration B is an annual integral calculus competition conducted among students of MIT in order to find their Grand Integrator of the Year. Now let's look at the problem here. Here we have integration of under root of x, and inside we have cube root of x, and then we have fourth root, fifth root of x. In fact, it is going up to infinity. Now take a pause here and try solving this on your own and continue watching for the solution. Now let's start by taking a more simplified and finite case. Let's take a look at the question where we don't have any of these and just have integral of square root of x dx, which is extremely easy to evaluate, and that's integral of x raised to power 1 by 2 dx, where you just have to add 1 to the exponent and divide the whole thing by same 1 plus exponent and add constant to the answer, which in our case is 1 by 2 plus 1. So our answer comes out to be x raised to power 3 by 2 divided by 3 by 2 plus constant. Now let's try going one more step further and get rid of fourth root of x and try to evaluate integral of square root of x times cube root of x dx. Now let's split this to square root of x times square root of cube root of x dx. Now we can write square root of x as x raised to power 1 by 2 and square root of cube root of x as x raised to power 1 by 3 times 1 by 2 dx. Now this gives us an idea on how to approach this much more complex general case, because now we know that we can simply distribute square root and then cube root and then fourth root and so on to get some power of x and then multiply them to get x raised to power n to evaluate this integral. Now that we know how to approach this question, we can start by breaking up this square root of x to x and this rest of the part. So now we can write it as square root of x and square root of cube root of x times fourth root of x times fifth root of x until infinity. Now we can break apart cube root of x to x and this crazy extended part, which is going to get us square root of x, square root of cube root of x, square root of cube root of fourth root of x times fifth root of x times and so on. Now let's do it one more time with fourth root of x and we get the following. Well, now we know how to simplify this. Here we have integration of x raised to power 1 by 2 into x raised to power 1 by 2 into 3 into x raised to power 1 by 2 into 3 into 4 into x raised to power 1 by 2 into 3 into 4 into 5, which goes up till infinity dx. Now we can write the exponent as x raised to power 1 by 2 plus 1 by 2 into 3 plus 1 by 2 into 3 into 4, which goes until infinity dx. Now do you recognize this exponent? Can we simplify this exponent to some constant? You may recognize this. Let me write down one more step for you. Now it is easier to see that we have reciprocals of sum of factorials going up to infinity in this exponent, which can also be written as. Now do you recognize this? Do you think this expression is similar to something that we have also learned in calculus? Well, you may think of E as one more definition of E as per Taylor series is 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial, which goes up to infinity, and in our case this x is 1. Now we can substitute our exponent by e minus 2 By using our general formula of x raised to power n dx, you can simply integrate x raised to power e minus 2 dx to x raised to power e minus 1 divided by e minus 1 plus c. Hence, you can solve any expression with nested infinite roots using this technique. I hope you liked this video. Please don't forget to subscribe my channel for upcoming videos.